Hello, so this is a simple differentiation problem. Y equals 4x to the 6 minus 2x squared plus 5x minus 3. And you can see that the expression here on the right of the equal sign is made up of power terms and a constant at the end. So we're going to differentiate. We start off by differentiating y, and if you differentiate y, you get dy dx. Okay? That's the most unusual case we're going to see, but anytime you differentiate y, you're going to get dy dx. Okay, so now we go along and we just work term by term. So the first term, 4x to the power of 6, that's a power term, x with a constant term. What we do, the rule for power terms is you multiply down by the power, so we're going to multiply 6 times 4, which is 24, and then we reduce the power on x by 1, so 24x to the power of 5. Okay, so again, what we did, we multiplied down by the power, so 6 times 4 is 24, and reduced the power on the x. Now, the next term is, excuse me for that. So, the next term is negative 2x squared. So multiply down by the power. 2 times negative 2 is negative 4, and reduce the power by 1, so x squared just becomes x. The last one might be a little bit unusual when we see 5x there. But 5x is actually the same as 5x to the 1. Now we don't usually write the 1, but let's put it in there this time. So multiply down by the power. 1 times 5 is 5, and reduce the power by 1 would be x to the 0. Okay, now we'll change that in a second. In fact, we can change it right now. X to the 0, anything to the power of 0 is 1. Okay. So anything to the power of 0 is 1, so this just becomes 5 times 1, or simply 5. And then the last term is negative 3, and negative 3 is a constant, and negative 3 just disappears. Okay, so we'll just make a note of that. It just disappears. Now, we should address why that happens. Okay, so let's see why that happens. We've got negative 3. Okay, well, negative 3 is the same as negative 3 times 1, so we're making it a little bit more complicated because the reason for this is hidden. But 1 can be written as x to the power of 0. Okay, that can be written as negative 3 times x to the power of 0. Now, if we differentiate, we multiply down by the power, so that means we're going to get 0 times negative 3, and then we'll reduce the power by 1, so x to the power of negative 1. But it doesn't matter what x is, because if we multiply by 0, we're always going to get 0. And that's why you start off with a constant, you always end up with getting 0, or in other words, you just leave it out of your work altogether. Okay, so remember, multiply down by the power first, then reduce the power. Let's hope this surface works. Multiply first, multiply by the power first, and only then reduce the power. And constants disappear. And anything that is a next term, for example the 5x, that will just end up as the constant. So 5x, the x disappears, but you keep the constant. Okay, so anytime you have an x term, your answer when you differentiate that term is just going to be the constant. Okay, that was a short video.